Hello, today we'll discuss the variation of the current and voltage in a purely capacitor circuit. Now we can see here this is alternating voltage supply which is connected to this capacitor and the current is flowing through the capacitor. So for the reference purpose we have taken here applied voltage and this is a current which is now leading to the voltage by almost 90 degrees. Okay, so for the sake of the simplification, we have considered very small change in voltage for very small change in current. Okay, so we have considered the small change in voltage for small change in current. Therefore, suppose the instantaneous value of the applied voltage to the capacitor having capacitor C is represented by V. This is instantaneous voltage is equal to Vm sine of omega t is equal to Vm sine of 2 pi f t. This is equation number 1. So what is this V? This is the instantaneous value of the voltage applied to a capacitor, which is having capacitor of C farads, Okay. So therefore, we have considered if the applied voltage increases by the small amount dV in the time dt as shown in the figure, then we can write the current flowing through the capacitor C is equal to V into dV by dt. This is the equation for the current which is flowing in the capacitor. So for that we have to put here value of the instantaneous value of the voltage, that is Vm sine of 2 pi ft. Okay. So we have to differentiate this value and we can write here this 2 pi hello sir. Okay, okay. चालेल चालेल ना सर. हो चालेल चालेल सर. हो चालेल सर. हो नाही चालेल. नाही नाही हो चालेल ना सर, काय प्रॉब्लेम नाही, तुम्ही करा कॉल. ओके. हो हो चालेल चालेल. ठीक आहे. ओके ओके. So here we are differentiating this quantity Vm sine 2 pi ft. So this is a 2 pi f is outside, C is, and therefore this is a constant, and therefore differentiation of sine 2 pi ft is the cos 2 pi ft. Okay. Therefore we can write here I is equal to 2 pi fc. This we can also write Vm, and this we can write sine of 2 pi ft plus pi by 2. Okay, we can write like this. So by comparing equation 1 and 2 shows that the current leads the voltage. The current leads the voltage by the quarter of a cycle, like this. So here this is the current which is leading to the voltage. Sorry, this is the current which is leading to the voltage by the 90 degree. Okay, this is a pi by 2 means 90 degree. So this is the phasor diagram for this is a phasor diagram for a purely inductive circuit. Okay, in which the current is leading to the applied voltage by 90 degree. Okay. Therefore, from equation 2, we can write here from equation, what is equation number 2? We have got this equation 2 pi fc vm sine of vm sine of 2 pi ft plus pi by 2. Okay, so therefore we have to compare this with the, it is vm sine uh, im, we are writing for the current omega t, and we can also write this sine of 2 pi ft. So if you compare these equations, we can say this is the im. So here im is equal to 2 pi fc vm. Okay, therefore we can write here vm by im is equal to 1 over 2 pi fc. We can write like this, and this is called as the capacitive reactance. Further, we can write if V and I are the RMS values, therefore we can write V by I is equal to 1 over 2 pi fc, and this is called as the capacitive reactance. This is called capacitive reactance. Okay, and the capacitive reactance express here. Capacitive reactance we can write here, it is expressed in ohm, therefore I is equal to, we can write I is equal to 2 pi fc v, and therefore this is v over xc. We can write like this. So here current is inversely proportional to the capacitive reactance. We can say frequency is inversely related to the capacitive reactance, and the current is directly proportional to the frequency. By considering this, we can write here in this case it is a reactance and current, and here it is a frequency. So if you calculate current versus frequency, the current is directly proportional to the frequency here. So it is like this. Current is directly proportional to the frequency. And here frequency is inversely proportional to the reactance, capacitor reactance. Therefore, it is a capacitor reactance. This is a capacitor reactance because frequency is varying inversely proportional to the capacitor reactance. And this is a current. Current is varying directly proportional to the frequency. Therefore, Xc is equal to, that is a capacitor reactance is equal to 1 over 2 pi fc. Okay. So capacitor reactance is inversely proportional to the frequency, and the current produced by the given voltage is proportional to the frequency. And this unit is ohm. Okay. Thank you very much for watching the video. Thanks.